Have you ever wondered what the universe is really made of? We see stars, planets, and galaxies, but deep down, beneath the tiniest particles that make up everything, could there be something even smaller? Something more fundamental? Welcome to the mind-bending world of string theory, where the very building blocks of the universe are not particles, but tiny, vibrating strings. In the world of modern physics, particles like electrons, quarks, and photons are considered the most basic components of matter. We think of them as tiny points, too small to be seen, just existing at a single location in space. But string theory offers a different vision. Instead of point-like particles, imagine every particle being a tiny, vibrating string of energy. These strings are unimaginably small, so small that, for all practical purposes, they seem like points to us. But their secret lies in how they vibrate. Just like a guitar string can produce different notes based on how it's plucked, the vibrations of these cosmic strings determine what kind of particle they become. One vibration might create an electron, another could form a photon, and yet another a quark. And it's not just the type of particle that's defined by the string's vibration. Even the mass, charge, and the force it feels are determined by these vibrations. Every fundamental property of every particle in the universe could arise from the dance of these strings. But here's where things get truly mind-blowing. String theory doesn't just work in our familiar 4 dimensions: length, width, height, and time. To make the mathematics of string theory work, we need extra dimensions, hidden ones. String theory proposes the existence of 10, even 11 dimensions. These extra dimensions are curled up into shapes so tiny that we don't notice them. They exist at every point in space but are hidden from our everyday experience, like tiny loops or folded planes. It's like an ant walking on a thin wire. From a distance, the wire looks one-dimensional, just a line. But if the ant gets closer, it can move around the wire, revealing that there's actually a second dimension hidden in plain sight. These strings themselves come in 2 main types. Open strings, which have 2 free ends. Closed strings, which form loops with no ends. And one of the most exciting ideas in string theory is that closed strings might be responsible for one of the most mysterious forces in the universe, gravity. Specifically, a closed string vibrating in a particular way could give rise to the graviton, the particle that mediates the force of gravity. This is a huge deal because it means string theory might help us finally understand gravity at the quantum level, something that no other theory has been able to do so far. And it doesn't stop there. String theory is often linked to another idea called supersymmetry. According to this theory, for every known particle, there's a much heavier superpartner. Electrons would have selectrons. Quarks would have squarks. It's a theoretical framework that could help string theory solve mathematical problems, but the challenge is these superpartners haven't been observed yet. They remain hypothetical. But the real promise of string theory is this: it might help us unify all the fundamental forces of nature. Right now we have separate theories for gravity, electromagnetism, and the nuclear forces. But string theory could bring all these forces together under one grand, elegant theory. A theory of everything. That's why so many physicists are captivated by string theory. It offers the potential to explain everything from the tiniest particle to the largest galaxies in the universe with one unified picture. But there's a catch. Despite its beauty, string theory is incredibly difficult to test. Right now, there's no experimental evidence for extra dimensions, supersymmetry, or even the strings themselves. It's a mathematically rich framework, but without evidence, it remains a theory in search of proof. And one of the wildest ideas to come from string theory? The possibility that our universe is just one in a vast multiverse. Multiple universes, each with different laws of physics, might exist beyond our own. So where does this leave us? String theory offers a tantalizing glimpse into the fundamental workings of reality. It may be the key to unlocking the mysteries of the cosmos. But for now, it remains a beautiful idea, waiting for the day we can find the evidence that could change our understanding of the universe. Forever. Until then, the universe continues to hum, to the cosmic vibrations of tiny, invisible strings. Subscribe for more explorations of the universe, science, and the mysteries that surround us.